Then similarly, the probability of k calls in progress during at a time t is a p of k. Then the probability of transition from k to j. K to j means nothing but it is already means the ending the call. Again, that state will be uh, move to the j state. The k state will be moved to the j state, busy trunk during the delta t. Then it will be represented by p of k to j, that is equal to p of k into p of p. That is equal, what is p of p? P of p is nothing but the, this is a terminating, the probability of the terminating call. Okay, p of k into delta t by h. Okay, this is a two equation, the probability transition between the k to j. Again, the probability transition from j to k during the busy trunk. Okay, then the both the equation, the probability transition from k to j and then probability transition from j to k, the both are statically equilibrium. Then equating both the equation, then we get p of k. What is p of j to k is the p of k into delta t by h, and what is p of j? The p of k to j is nothing but p of j into a into delta t by h. Here p of k, the p of k is equal to here delta h by delta h, both are said RHS and LHS said the delta h will get cancelled. The remaining you will get p of k is equal to a by k into p of j. This is the equation. This is a statistical equation, that is p of p is equal to a by k into p of j. Okay. Suppose in this model, this is a general equation, we'll get it. Okay, the k will be from 0 to 1. Correct now? From 0 to n. Okay, initially we tell we are to show the state transition diagram. The k will be vary from 0 to n. It may be 0, kn minus 1, kn plus 1. Finally, we'll get n only. Then suppose the first transition state. Okay, that suppose I'm taking a p of 1. That's the first transition state p of 1. The k is equal to 1. IS state 1 is equal to 1. Then a, what is k? K is equal to 1. See, k is equal to, suppose I'm considering k is equal to 1. Okay, it will be vary from 0 to n. Okay, the k will be vary from 0 to n. This is the calls. Okay, this is a progressing calls. Then suppose the p of k is equal to 1, then p of 1 is equal to, the p of 1 is equal to, you put k is equal to 1. P of 1 is equal to a by 1 into, what is the j? P of j is the 0 state. Okay, the p of k is the next IS state. Okay, p of j is the next IS state. Okay, we can see here. See, the probability. See, you can see observe in this statement, in this slide. You can observe this statement. The probability of j, the probability of p of j is the p of j is the probability of state j, and p of k is the probability of the next IS state. Okay, p of j is the probability of the state j, and p of k is the probability of the next IS state. Suppose I'm putting k is equal to 1, putting the k value here 1, then in this equation, then p of 1 is equal to a by 1 into, what is j at present state? That will be a 0. Okay. Similarly, p of 2 is equal to k is equal to into p of 1. Okay, p of 1. Now using this equation is there now, p of 2 is equal to a by 2 into p of 1. See, initially we know that p of is substitute here, p of 1 is equal to a1 by p naught. Okay, then we will get a by 2 into a1 into p naught. Okay, a by 2 into a1, a by 1 into p of. Okay, then this equation, suppose if next to p of 3 you put it, p of 3 is equal to k is equal to 3, then p of 3 is equal to a3 by into p of 2. Again you substitute p of 2 is equal to this equation. Like it will be continuously going on till some n. Okay, some x. Okay, again this equation can generally you can written as a p of x is equal to a to the power of x by x factorial into p of naught. You can represent it in terms of general P of x is equal to ax by x factorial into P of 0. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಈಗ ನಾನು k is equal to 1 ಕೊಟ್ರೆ it's 1 is the next highest state. J is equal to present state. Present I am considering is 0. The next highest state I am considering a 1. K is equal to 1. In the previous equation ಏನಿದೆ, the P of k is equal to ak into P of j, you put k is equal to 1, the next highest state. Then P of 1 is equal to a by 1 into P of 0. Okay, then P of 2 is equal to a by 2 into P of 1. Okay, see P of 1, we know that P of 1 is equal to a1, a by 1 into P of 0. You substitute in the P of 2 equation, then we'll get a by 2 into a by 1 into P of 0. Okay, clear? Again, P of 3, k is equal to 3, P of 3 is equal to a by 3 into P of 2 will get now. Then we know that P of 2 value will be this only. You substitute here in that P of 3. The P of 3 is equal to a by 3 into P of 2. What is P of 2? P of 2 is equal to a by 2 into a by 1 into P naught. Okay. Again P of 4. Like that it will continues. Okay. Suppose P of x, considering P of x, in general you can return a P of x is equal to a to the power of x divided by x factorial into P naught. Okay. This is the equation you will get it. This is the equation we'll get it. Okay, and generally the return P of x is equal to a to the power of x by x factorial into P of 0. Okay, clear about this one? Any doubt regarding this? Any doubt? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Any doubt regarding this?
No, sir.
Okay, then in the assumption of pure chance traffic is implies a very large number of source. Thus x can have any between 0 and infinity, and then the sum of their probability must be unit. Then suppose that equation, what is the P of x equation will be, the x will be vary from 0 to infinity. Okay, in the assumption of pure chance traffic, what is the assumption we made for pure chance? Or both originating and ending terminating calls are the independent random variables. Correct now? Based on the assumption, what happened? The above P of x equation, the x will be vary from 0 to infinity. It will be vary from infinity. That should be equated to 1. The probability equation must be equated to 1. Then you put it here in this the equation of 1. The 1 is equal to summation of x is equal to 0 to infinity of P of x. Then what is P of x is equal to a to the power of x by x factorial into P naught of f. Then summation of a to the power of x by x factorial will be represented by e to the power of a into P naught. E to the power of a into P naught. Okay. You can also return P naught of it is equal to d to the power of minus a. If you go for other side, other LHS side, you will get 1 by e to the power of a is equal to P naught. You will get it now. Suppose 1 divided by e to the power of a will be represented by e to the power of minus a into P naught. Okay. Then again we can return as what is P naught will be a e to the power of minus a. Then P naught of x is equal to x by x factorial by e to the power of a. Okay, you are put it here. The P naught is equal to put it P naught P0 or P naught is under P0. P of 0 should be a e to the power of a. Clear? Then finally we'll get this equation P of x is equal to a to the power of x by x factorial into e to the power of minus a. Okay, clear? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? See, it is very simple derivation. Okay, we know this transition probability between the present and the next highest state. Then we'll get this probability equation. There's a P of k is equal to a by k into P of j. Okay, here the k will be vary from 0 to n or 0 to x. Okay, then first k is equal to substitute k is equal to 1. Then P of 1 is equal to a1 into P of 0. P of 0 will get it 0 means the 0 will be the present state, the k will be the next state. Okay, then P of 2 is equal to, then k is equal to, and in this equation put k is equal to for this equation. Then we'll get a by 2 into P of 1. What is P of 1? We know that P of 1 is equal to a by 1 into P naught of 0, P of 0. Then P naught of P of 2 is equal to A by 2 into A by 1 into P of 0. Okay, this equation like that we continued. Okay, P of 3, P of 4, P of 5, P of 6. Then we can expect a P of x in terms of x. P of x is equal to x by x factorial into P naught. Okay, then we should also find out what is the value of P naught. In the pure chance method, both the calls, okay, incoming and outgoing calls or arriving or terminating call will be originated in the independent random variable. Then the x will be vary from between any value between the 0 to infinity, and this sum of the probability must be equating to unity. Then 1 is equal to, then we can see the 1 is equal to e to the power of x is 0 to into 0, x is equal to 0 to infinity P of x. We know that P of x is equal to e to the power of x by x factorial into P of 0. Substitute here. See, summation of x is equal to 0 to infinity e to the power of x by x factorial represented by EA. Okay, we'll get is EA, exponential of EA, will get it. Then 1 is equal to, then we'll get 1 is equal to e to the power of A into P of 0. Then what is P of 0 is equal to 1 divided by EA. You take this other side, E of A will be taken to the left hand side, then 1 by EA is equal to P naught. Then the 1 by EA can written as a e to the power of minus A. That is a P of 0. Then you substitute P of 0 in the general equation of P of x. Then P of x is equal to e to the power of x by x factorial into e to the power of minus A. Okay, clear? This is the equation. Any doubt? Okay. Then see, this is your basic fundamental mathematical fundamental equation for the for telecommunication system. Based on the equation, we can develop a last call system and then queuing system. Okay, this is a last call and queuing system. Coming to the last call system, okay, the Erlang determined the grade of service of last call system having a entrance when offered traffic A. Okay, we have a number of trunks. Okay, it will be offered by traffic A. Its solution depends on the following assumption. We go for developing this mathematical model for last call system. We are doing some assumption. You have made some assumption. The first one is the pure chance traffic, and second one is the statistical equilibrium, and then third one is the fully availability, and then calls that encounter conjunction are lost. Okay, as usual, pure chance traffic, all call arrivals and terminations are independent random events, and statistical equilibrium implies probability of remains unchanged for the period being considered. The probability of the above equation is unchanged for the particular sum of the time period that will be considered in this model. And then fully availability, it means that all incoming calls can be connected to any outgoing trunk, that is free. Fully availability is nothing but all the calls will be connected to the any outgoing trunk, that is free. If suppose we have some outgoing trunks will be there, that will be some free trunks lines will be there, is nothing but if full all the connections should be connected for other trunks also to make the connection between the user. That is called as fully availability. Fully availability means each incoming call having a separate path, outgoing trunk will be there. Otherwise, another word we can also say here. Suppose in where the outgoing trunks will be free, no? In that outgoing trunks, the incoming calls will be connected. That's the one fully availability. And then the next one is the calls that encounter conjunction or lost. Okay, which is the basis on the which call loss system are classified. Suppose some conjunction will be encountered in the particular call, means that call will be lost. That is one assumption they made for this last call system, okay, which is on basis on the which last call system are classified. Okay, these are the 4 assumptions are made for the last call system. There is the first one is the pure chance traffic, statistical equilibrium, fully availability, and then calls that encounter conjunction or last. Okay. See, for the last call system, suppose there is a x number of calls. There is a x calls are in progress, and also we know that equation of the x calls. There is a probability equation of p of x is equal to e to the power x by x factorial into p of 0. There is the equation number 1. Suppose there cannot be negative number of calls and there cannot be more than n. Okay, it means that number of calls that should be vary from 0 to n. Okay, there is no there cannot be a negative number of the calls. There cannot be a more than n. Okay, it means that the x will be vary from 0 to n. That's why x0 is less than of x and less than of n. Okay, then put it here. The x will be vary from 0 to n, and summation of x is equal to 0 to n. See, we can see the summation of x is equal to 0 to 1. That should be equal to the summation of x is equal to 0 to n, a to the power of x by x factorial into p of 0. Okay, we know that p of 0 is equal to e to the power of minus a. That is the thing, we know that one. Okay. Then p of 0. Another p of 0 is equal to the p of n. P of 0 is equal to also we can written as a p of 0 is equal to 1 divided by, see, this is 1 divided p of 0 is equal to 1 divided by, see, by using this equation also. Okay, you see this x a to the power of x by x factorial will be shifted to the other LHS side. Then we'll get p of 0 is equal to 1 divided by 1 divided by, see, 1 divided by summation of n by x is equal to 0 to n e to the power of x by x factorial. We'll get this equation. Okay, clearly you can observe in the slide. Okay, don't confuse here. Okay, we need to calculate this p of 0. Okay, you substitute these. See, these things will be this summation of x is 0 to n into e to the power of x by x factorial will be moved to the another side. There is a LHS side. See, that is equal to 1 divided by, see, summation of x is 0 to p of x is equal to 1. That should be equal to the summation of x is 0 to n into e to the power of x by x factorial into p of 0. Okay, you can see these things will be shifted to the another side, LHS side. Okay, then p of 0, then p of 0 is equal to 1. As usual, this is a 1 divided by summation of x is 0 to n into e to the power of x by x factorial. Okay, this is the equation. Will get it. There's a p of, this is a p of 0. Will get it from this above equation. Okay, then substituting the value, this value, substituting this p of naught into equation number 1. Okay, substituting p of 0 in equation of 1. Okay, then p of x is equal to a to the power of x by x factorial divided by summation of what is p of naught. P of naught is equal to 1 divided by summation of x is equal to 0 to n into a to the power of x by x factorial. We substitute here. We'll get this is a p of x. This is the equation number 2. This is the equation number 2. Okay. Then this equation is there, na? This is the equation number 2 is called as a Erlang first law. It is also called as a first Erlang distribution. Okay, it's also called as a first Erlang distributions. Okay, the last call system formula is there now. There is a first Erlang distribution. Okay, suppose when x is equal to n, the x is equal to n. Suppose the x will be a higher value, means the x will be vary from 0 to n. Now, suppose when x is equal to number of trunks lines will be a is equal to n, then p of n is equal to is the probability that all calls encounter conjunction. That is the grade of service of the network. That will be represented by this equation. The grade of services. What do you mean by grade of services? The grade of services is equal to total call asked by the traffic offered. Call us by the traffic offered. By using that equation, we can calculate the grade of services. Okay, GOS. There's a grade of services that will be represented by B. Okay, that is represented by this is a B. That is the what is the total? There is a last call. There is a Erlang first law. There is a 1n is nothing but first law. There is a first Erlang distribution of A is equal to this is the equation. There's a n. Suppose I'm taking x is equal to n. The x is equal to higher number is the n value. There's a the x will be from 0 to n. Correct now? That's why I'm taking n. X is equal to n. Then a to the power of n by n factorial divided by summation of k is equal to 0 to n. K is equal to 0 to n into ak by k factorial. This is the equation for this. This is the equation for the first Erlang distribution. Okay, here I'm taking here for this equation what happened? I'm considering the x value will be vary from 0 to n. Correct now? The x value will be vary from 0 to n. Okay, here I'm considering the n value will be the x is equal to n. The x is equal to n. Then this equation will be the first Erlang equation will be a to the power of n divided by n factorial divided by summation of k is equal to 0 to n a to the power of k by k factorial. Okay, this is called Erlang last call formula. This formula is also called as a Erlang last call formula. Okay, and also we do some iteration. Then we'll get again. We can also what we can call remodification of the above equation. Then we'll get this equation. Okay, into the n minus 1 calls. Okay, we'll get this equation also. Okay, don't worry about this equation. You concentrate on only this equation. Okay, see this equation is also called as a last. This is Erlang last call formula. Okay, it means that we can easily remember last call system is nothing but is the first Erlang distribution system. Okay, in external exam they will ask this question, this kind of question. Derive an expression for the first Erlang distribution means you should write this expression. Okay, this is the Erlang first equation. That is your last call system for the telecommunication traffic. Okay, clear about this? Any doubt? Any doubt?
No, sir.
Okay. See, please everyone note on this. Everyone take down the first Erlang mathematical model. Everyone take down from here. Wait a minute. Take down from here. From here you should write the first Erlang formula. Okay, first Erlang formula is also called as a last call system. Please everyone, please note on this last call system. Answer attendance: Jayavardhan Reddy, Dilip Kumar, Dinesh.
Present, sir. Present, sir.
Okay. Abhishek, Rupashri,
Present, sir.
Subramanya Reddy,
Present, sir.
Sonika, Shreya,
Sir,
Jyoti?
Dilip Kumar present, sir.
Okay. Jyoti, and then Venkat, Murthy, Rameshri, Srinivas.
Sir, I am present, sir.
Okay.
Deep.
Okay.
Sir, Dilip Kumar, sir.
4 completed.
No, sir.
Okay, dear student, today we'll stop here. We'll continue in next class. Okay, next class you take down the remaining part.